This is Unit 7, Lesson 5, Functions, Part 1. There is no bell ringer today because we took a quiz, so we'll go to the next page. Let's just review function notation. This is something that you would have done last year, but they give you this function up here, 2x minus 2, and then they have the function table with all of these x's right here. So you're going to take each x and plug it into the function. So we'll do 2 times negative 4 subtract 2. So that would equal negative 10. And then you'll do 2 times negative 1 subtract 2. So negative 4. 2 times 1 subtract 2. So that would be 0. 2 times 4 subtract 2 would be 6. And 2 times 5 subtract 2 would be 8. Okay, now we have function notation down below. If it starts with an f, like this row right here, you'll pair it with the equation that says f of x. If it starts with a g, you'll pair it with the equation that says g of x. So we'll do a few of these, and then I want you to finish the rest on your own. So f of negative 5 means that x is negative 5. So I'm going to take the f of x function up here and plug negative 5 in where the x is. So I'll have 3 times negative 5 squared minus 3 times negative 5. And then I just need to simplify that. So I would have 3 times 25 and then plus 15. If I kept going on that, I'd end up with 90. So f of negative 5 equals 90. Okay, now on the next row, I have g of 7. So I'm going to use the g equation up here. So I'm going to plug 7 in where the x is. So negative 2 times 7 plus 4, and simplify that. So I would get that g of 7, so the function evaluated at 7, equals negative 10. Okay, another example, we'll use h of 4. I'm going to use this function up here. Plug the 4 in where all the x's are. So I'll do negative 5 times 4, subtract 1. So that ends up simplifying down to negative 21. So the function h evaluated at 4 equals negative 21. Okay, and now for the k of negative 4 right here, I'm going to use the k of x function up at the top. So I'll do 4 times negative 4 squared minus negative 4. So if I go through, that's 4 times 16 plus 4. That ends up simplifying down to 68. So the function k evaluated at negative 4 equals 68. So I want you to go through and do the other 8 using the correct function at the top of the page, and then you can check your answers on Canvas on the filled in notes page. Okay. Goran purchased a prepaid phone card for $40. Calls cost 25 cents per minute using this card. The credit C in dollars left on the card after it is used for X minutes of calls is given by the following function. How much credit is left on the card after Goran uses it for 40 minutes? So all we're going to do is take the 40 and plug it into the function and simplify it down. So I have C of 40 equals 40 minus 0.25 times 40. So 40 minus 10. So the function evaluated at 40 minutes of talking on the phone is equal to $30. Okay, on this next section, we are going to use a website called Desmos. The website is desmos.com/calculator. We're going to compare all of these graphs to this original function right here, f of x equals x. When we type it into Desmos, we're just going to use y instead of f of x, so y equals x. And then, for example, down here, we'd type y equals x plus 2. And we're comparing all of these functions down below, so a through L. We're comparing them with the original function of y equals x to describe how they change. So let's go over to Desmos. And I'm going to type in my original function. So up here in the upper left side, I'm going to type y equals x, and then it'll graph it over here. Then on part A, I have y equals x plus 2. Okay, so I'm comparing those with each other. If you look at the original one, the blue one, you can see that the green one has been shifted up 2 units. So on my notes, I'm going to write that function A has been shifted up 2 units. Okay, now when I go back to Desmos, I'm going to clear out the function that I had, the x plus 2, by just clicking this x, and I'm going to type in my next one. So part B is y equals x minus 4. So when I compare it to my original function, the blue one, you can see that the new one has been shifted down 4 units. So on my notes, I'm going to write that it has been shifted down 4 units. Okay, let's do part C. So I'm going to clear out my function and I'm going to type in y equals 2x. Okay, so you can see that they both start at 0, but the black one has been kind of stretched up by 2 because the slope is 2. So we call that a vertical stretch of 2. Okay, let's go down to E. So I'm going to type y equals 1/2 x. Okay, so the original one was the blue one. The red one you can see has been kind of like shrunk down. So we call that a compression. So a vertical compression of 1/2. Okay, and then let's do G, and then we'll stop and have you guys do some, oops, sorry. Okay, G is y equals -x. Okay, they're both blue, that's not really helpful, but the one that we just did has a negative slope, so it's actually a reflection over the x-axis, over the y-axis. In this case, it doesn't really matter because they're the same. But when you have a negative, that means it has been reflected. So we're going to say a reflection over the x-axis. Okay, so I want you to go onto Desmos and do the rest of these that you haven't done yet. And then please check your answers on Canvas on the filled in notes. And then you can go ahead and start on your homework.